The electrolysis of aqueous copper 2 sulfate using copper electrodes. In the beaker here you see a blue aqueous solution of copper 2 sulfate, and here you see a copper electrode. This one on the right is going to be connected to the negative terminal, so this will be the anode. This electrode here with the bulb on the side, this will be connected to the positive terminal, so this will become the anode. The power pack is on. I'm using 9 volts roughly, direct current. If I was to connect these two electrodes together, that would complete the circuit. And as you see, the bulb lights up. I'm going to place them into this beaker of copper sulfate, and I'm going to keep the two electrodes apart using this little piece of card here so that they don't touch. But you'll notice that when I put them into the solution, the bulb does light, which means that the circuit is complete. In other words, the aqueous copper 2 sulfate is indeed an electrolyte, a solution containing mobile ions capable of conducting an electric charge. Okay, I've let the electrolysis run for just over half an hour. I used around about 9 volts direct current, and I'm going to take a look at the two electrodes. Let's take a look at the left hand electrode first of all. That's the anode, the positive electrode. Remember what we expected to happen here. We expected hydroxide ions, OH- from the dissociation of water, as well as sulfate ions from the copper sulfate to be attracted to the left hand electrode. However, neither of those ions was discharged. Neither of those ions underwent oxidation. Instead, the electrons came from the copper anode itself. Copper atoms, Cu, turned into copper ions, Cu2 plus 2 electrons. And as a result, as I take out the left hand electrode here, we expect to see that it has worn away. So after half an hour, this is what the left hand electrode looks like. And you can clearly see here that the electrode has disintegrated, and most of the electrode that was submerged in the electrolyte has now actually disappeared. The copper atoms have turned into copper ions and gone into solution. Okay, what about the right hand electrode? In this case, the right hand electrode is connected to the negative terminal, so this is the negative electrode. This is called the cathode. Recall what happened here. Copper ions and hydrogen ions in the solution, hydrogen ions that is from the dissociation of water. Those two ions were attracted to this electrode. However, since the copper ions more readily undergo reduction, they are discharged, the hydrogen is not. So what we expect to see here is evidence of the following. Copper ions in solution having changed into copper atoms, insoluble copper atoms, and we expect to see that this electrode has grown in size. So let's see what we get here. And again, if you look just along the edge of the electrode here, you can clearly see a deposit. There's a degree of thickening of this electrode. You can see that copper has built up on its surface. So this is the copper cathode, the negative electrode, where copper atoms in the solution have arrived to undergo reduction. Cu2 plus 2E- produces insoluble copper atoms, and this electrode has grown in size. It's significantly pinker in colour as a result of fresh copper having been produced. The copper sulfate solution itself is still blue. There is no net change in the copper sulfate solution, since while we were removing copper ions at the right hand electrode, changing those into atoms which deposit on the electrode, on the left hand side the opposite was happening. We were turning copper atoms of the anode into copper ions which go into solution. So copper ions are going into solution at the left hand electrode and coming out of solution at the right hand electrode. So no net change in the copper sulfate solution. You may be able to see some deposit there at the bottom of the beaker. That completes my look at the electrolysis of aqueous copper sulfate using copper electrodes. You should also go on to consider how this particular electrolysis process is used to refine blister copper, and what's known as the electrolytic refining of copper.